Hey everyone, Team Connections, which is Terence Walton, Brent Greyson, Faith Miller, and Jonathan Kinsey, bring you this week's chapter on client-server network. The roadmap is going to be first a review on some of the networking topics we've already covered. We're going to talk about what client-server networking is. We're going to talk about network layers, and then we're going to put the pieces together for you in a really practical way. So with that said, we'll move on to Faith, who's going to be telling us a little bit about the networking stuff we've covered, and then client-server network.
Thanks. Hey guys, let's jump into Network 101 review. The first topic was network design basics. We learned that good networks don't happen by accident. Intentional planning improves reliability and scalability. In education, this means that students and staff have consistent access to both classroom and administrative needs. Strong design is a foundation for a secure and sustainable network. Moving on to our next lesson, we learned that servers are the backbone of digital learning. Client-server models allow real-time content delivery, whether it's assignments or resources. Modern practices include cloud hosting and add scalability and automatic updates, while bandwidth and latency shape our user experiences. Compliance with FERPA and COPA and strong leadership decisions are all critical in keeping these systems secure and reliable. Last week, we talked about databases, and we learned that they serve as a central hub for storing and moving large volumes of data. It's used to automate account creation, connect tools like Office 365, Google, and LMS platforms, along with saving time through integration. Security here is also a must, and protocols like SFTP protect sensitive data, and automation help reduce errors while also ensuring data accuracy. So let's look a little bit more into what client-server networking is. Client-server networking is a setup where we have two types of computers that work together. The client is the user's device. Think your phone, laptop, tablet, those type of things. And the server is a more powerful computer that stores the files and applications or services. So when the client needs something, it sends a request to the server processes that request and then sends that information back to the client. This relationship between client and server is really what makes most of our digital systems work. So when you use your device to open a website, log in to an LMS, or download a file, your device is sending that request to the server. The server then processes that and then sends that information back to you. So the setup is efficient because everything is stored and managed in one central place. The server and multiple clients can access it at the same time. It also makes things like updates, security, and resource sharing so much easier. So once something changes on the server, it's normally automatically applied to everybody in that connected client. I'm going to turn it over for a little bit about network layers.
All right. So in order to really dig into client-server networks, we really need a solid understanding of what are known as network layers. So what you see on the screen here is the Open Systems Interconnection, or OSI model of network layers. It helps us visualize the way networks send and receive data. There are 7 layers in the OSI model: application, presentation, sessions, transport, network, data link, and physical. This is also sometimes called the network stack. The top 3 layers of the stack, application, presentation, and session, are referred to as the software layer. The bottom 3 layers of the stack, network, data link, and physical, are referred to as the hardware layers. The middle layer, transport, is the heart of the OSI model and the layer that facilitates data transfer between software and hardware. Another way that you may hear about networking in practice is moving either up or down the network stack. When data is sent, it's moving down the stack. When data is received, it was moving up the stack. Next, we'll take a short journey through each layer of the network stack, define it, show an example, and give you some practical questions that you might be faced with in your current or future ISDT role.
So the application layer is where most folks are going to interact with software and applications. It's the digital interface where you send and receive that information that Brent just talked about. From a more technical perspective, the layer consists of protocols, commonly known as HTTP, HTTPS, and FTP, that enable the software and applications to exchange data across the layers. So in practice, applications that we use commonly include learning management systems or student information systems. When you're engaging with these systems, like Cornerstone, Canvas, or Blackboard, you're interacting with the application layer. When it comes to making decisions about technology purchases or operations, you may want to think through whether or not applications like an LMS are accessible, usable, or aligned with the end user's needs. Moving a little deeper into the next layer, the presentation layer focuses on translating and formatting data behind the scenes. It helps to make sure that data is in a usable form, like a specific file type, for example. Within this layer, encryption, decryption, and compression of data occurs. If you're receiving data, this layer is translating the data for presentation up in the application layer. If you're sending data, this layer translates it back for the network layers below. Translating data around file formats is a common example of what occurs in the presentation layer. The format of a file helps tell the presentation layer how the data needs to be translated up or down network layers for transmission. In practice, you may want to consider how file types are assisting you in protecting sensitive data. Which format would you choose? How might you encrypt that file before you send it? When thinking in the context of selecting a learning management system, you might also consider if the learning management system has the ability to enable users to securely transport and translate their files through the presentation layer. Going another layer deep into the session layer, this is the layer where applications begin to have conversations with each other. This is the layer that's concerned with starting, maintaining, and ending communication connections or sessions between a server and clients. The session layer is the mechanism that keeps longer running tasks between systems running. These could be logins to servers or video teleconference calls. A session synchronizes data exchanges and enables that real-time communication over platforms like Zoom or Teams. Carrying that telecommunications theme forward, voice over IP phone systems heavily rely on the session layer to ensure that your conversations occurring over the network feel synchronized and responsive. These types of phones will package audio as digital packets and securely send them over the internet instead of through an analog telephone line. When thinking about this layer, you may consider if the systems are able to ensure that sessions are secured and that timeouts are set up to appropriate links between systems. This might align with how we do synchronous online courses over Zoom or Teams. Can these systems ensure that students join and stay connected synchronously? Now I'm going to hand it over to Terence to talk about the next couple of layers.
The transport layer plays a critical role in the OSI model by managing end-to-end communication between devices. It is responsible for keeping track of individual conversations, ensuring that messages are delivered accurately, in sequence, and without duplication. To accomplish this, the transport layer breaks large data streams into smaller, manageable segments and reassembles them correctly at the receiving end. It also provides error detection and correction mechanisms to guarantee data integrity. Two key protocols operate at this layer. Transmission Control Protocol, or TCP, provides reliable connection-oriented communication that is essential for applications such as web browsing, email and file transfers. User Datagram Protocol, or UDP, offers a faster, connectionless option well-suited for real-time services such as streaming, online gaming, and voice over IP. In short, the transport layer ensures that digital conversations between systems remain clear and reliable, as well as properly managed. Different types of applications rely on different transport protocols. For example, web browsing uses the Transmission Control Protocol, ensuring that every packet of data arrives complete in order and without duplication. This makes it the best choice when precision is more important than speed. In contrast, video streaming and online gaming often use the User Datagram Protocol, or UDP, which is faster because it avoids the overhead of constant error checking. A few drop packets will not interrupt a video game or stream, but the reduced delay significantly improves the user experience. The network layer is responsible for determining the physical path that data should take across interconnected networks. It takes the transmissions from the transport layer and breaks them into smaller units called network packets. To direct these packets, the network layer relies on Internet Protocol addresses, or IP addresses, which serve as digital street addresses. These logical identifiers allow devices to send and receive information even when separated by great distances or different network technologies. It is important to note that IP addresses are logical, generally temporary identifiers. Unlike a permanent hardware address, such as a MAC address, an IP address can change as the device connects to different networks. In essence, the network layer ensures that every packet of data knows precisely where it's going and how to get there, making large-scale communication across the internet possible. When you create a course in Blackboard, the network layer ensures you connect to the platform whether you're on campus, at home, or across the globe. Routing is designed to be efficient and secure, with redundancy in place to avoid a single point of failure. However, if you need to access on-site servers from off-campus, for example, uploading course materials stored on a campus network, you may also need additional networking components such as a VPN or firewall to provide both secure access and reliable connectivity. The data link layer ensures data travels correctly from one device to the next, typically within a single network segment. It uses media access control addresses or MAC addresses, which act like digital name tags. Unlike IP addresses, MAC addresses are permanent once again, and hardware-based identifiers similar to serial numbers. The data link layer. This helps ensure every chunk of an assignment upload travels from a student's laptop to the campus Wi-Fi access point without getting corrupted. Network switches must be properly configured and monitored to prevent errors or bottlenecks. And just as the data link layer ensures accurate delivery of packets, integration between the SIS and LMS must be carefully managed so that enrollments are never missed and courses are not deleted during synchronization. The physical layer. This moves rare binary bits, ones and zeros across cables, fiber, or wireless. It defines the plugs, ports, and signals that carry the data, sending electrical or optical signals to represent digital information. The physical layer underpins whether learners can reliably access content on an LMS. Wired Ethernet offers faster, more stable connections, reducing video buffering and synchronous learning. Wi-Fi provides flexibility but may introduce lag during live discussions or VR-based simulations. That's why it's essential to ask, are the physical connections and their components reliable and built with redundancy? And is the Wi-Fi network strong enough to support users across the school? With proper planning, capacity management, and regular upgrades, a campus Wi-Fi system can deliver the consistent access needed for teaching and learning.
So now let's take this information that we've shared with you guys and put the pieces together with some real life examples of how and what happens with networks. I'll go first. So I was thinking back to when I was teaching and the STAR test first went fully online. So we've got students all across our district and all across the state of Texas signing in at the same time. Some are getting in, some aren't getting in. And then those that were able to get in are working along. And then the test just freezes. They can't move forward. They can't move backwards. They can't get in or out. The entire system went down. Looking back, after learning a little bit more about these network layers, it seems that the fault was within the application layer, where the platform itself wasn't able to handle so many requests all at once. And then when you're looking at the transport and network layers, they kind of struggled to move all that data as quickly as it was being sent and received. And then that data link and physical layers is where those hardware connections just weren't able to keep up with the flood of all that traffic. So it was really interesting for me as we're working through this unit to be able to make that connection. Now I will turn it over for the next story.
Back at it. I just want to share a quick story in regards to some experience with networking I have with servers and databases. We had a situation where one of our applications kept randomly dropping connections. At first, everyone thought this problem was within the software or the database itself. However, we started digging deeper. It turned out the issue was happening at different OSI layers underneath. At the data link portion, we noticed some errors on the switch ports, kind of like when traffic lights are at an intersection and they start glitching. Then at the network layer, we discovered routing loops, which is like your GPS sending you around the block simultaneously in the same circle. Finally, at the transport layer, that meant user sessions were timing out, almost like packages arriving out of order or arriving at all at a FedEx center. Once we fixed the loop and stabilized the ports, the application ran smoothly again. What was interesting is that for the users, it looked like a database problem, but really it was the lower layers quietly doing their job that made everything work. That is why when assessing or procuring systems, it is important to ask simple, practical questions like, are the physical connections and switches reliable? Is the routing secure and efficient? And can the applications actually handle sessions without disruption? Getting those right makes the higher level stuff like the database or software run much more smoothly.
So I wanted to share a story as well about a time that I had a continuing education client that wanted to enroll about 7,000 students in a training course over a 3-month period with LinkedIn Learning content. To accomplish this enrollment, we used a combination of different cloud-based systems. The system administrator uploaded a CSV file to our SIS and received an email back from the server indicating that about 5% of the rows in the CSV didn't successfully enroll. So I chalked that up to something that was going on in the presentation layer of the network where there was an issue with some of the encryption. So those 5% of learners were re-uploaded and successfully done on the second try. From their learner dashboard, they were able to find and access the course they were enrolled in. And when the learners clicked on that course, the SIS sent a request over the application layer to the LMS server to authenticate the learner and log them into the course. One of the content links in that course performed another network request through an LTI so that the learner could access LinkedIn Learning. They primarily relied on that application session and transport layers to ensure that their account gained access to the module content and sent their grade back to the LMS gradebook accurately from LinkedIn Learning when they were done with the module. So back in the LMS and the SIS, nightly automations are used in that presentation session, transport network, and data link layer to download grades from the course and store them back in the student information system for weekly automated reporting via email. So a lot of different interconnected systems there in that story. And it reminded me a lot of that this week when we were talking about network-based interactions between servers and clients.
Well, thanks you guys for sharing those stories. I suppose we'll leave it here. The references will pop up in just a moment, and we will put the prompt for this week's discussion in the discussion board post underneath our video. So we'll see you in the discussion threads, and thanks for listening to our lesson. Bye.
Hey guys.
Yeah.
Bye.